Hello again, AAF kids. Sorry for deserting you. It seems like too many times, right? I apologize for that. But I am with my daughter up in Boston and my other daughter in Philly. So for your warm-up, if you could pick up the unit circle that the substitute has and fill in, just and see if you can do this fast and without notes. If you need your notes, that's fine, but you want to practice, because coming, right, you want to announce that starting next week, but you don't know exactly when, speed trig quizzes. So any day next week, I will not tell you which days. It could be at the beginning of the lesson, in the middle, or at the end. I could say put everything away except something to write with. You have 10 minutes. The first speed quiz, you have 10 minutes for 10 problems. They're all right or all wrong. No partial credit, no follow through. All right or all wrong. Then at some time later, there will be speed quiz number 2. This one will take you, you get 8 minutes to do 10 different problems. No partial credit. Problems are either right or wrong, and they're all unit circle values. They are all just unit circle. Unit circle values only. No combos, no like trig expressions, just cosine of 45 degrees, secant of 7 pi over 6, tangent of 90 degrees, cotangent of pi, right? Any of those quiz. And then finally, the last speed quiz, 5 minutes to do 10 different problems. And that's over about 10 days. These problems. Now, here's the good news. What we will, for your grade book, what actually goes in the grade book is only 1 grade. What we will do is, of the 3 grades, I will drop your lowest score. Right? Drop the lowest score, average the next 2. So, for example, let's say you get a 5 on the first one, then you get 2 10s on the next one. The 5 is dropped, 10 plus 10 divided by 2 is 10. So your actual score would be a 10. Let's say you get an 8, a 9, and a 10. The 8 is dropped, 9 plus 10, 19 divided by 2, 9.5 would be your quiz grade. Right? Let's say you get a 0, gasp, and then you get a 7 and you get a 9. Right? 9 and 7 is 16. Half of 16 divided by 2, 8 would be your score that is recorded. So this grade, this last one, is the only one that is recorded in the quiz category. But we're going to be taking over the next, right, 7 to 10 days, 3 speed trig quizzes. You don't know when they're coming, but it could be as early as Monday. Get ready. So picking up this unit circle and filling it in one of the things that can help you practice. Now notice I'm asking you for the sign coordinates only, and also the coordinate sign. So here's what I mean by that. I want you to fill in, oh dear, I want you to fill in quadrant 1, right? Sine, cosine, and tangent are all positive. None are negative. In quadrant 2, only sine is positive. Cosine and tangent are negative. In the third quadrant, this doesn't account for the boundaries, right? So just in the third quadrant, only tangent is positive. Sine and cosine are negative. And in the fourth quadrant, only cosine is positive. Sine and tangent are both negative. Right? And in the boundaries you know just by being at the ends, right? 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So I want you to fill in 0 degrees and 2 pi radians, 30 degrees, pi over 6 radians, and all the way around. Ah! It's not 4/3 pi, is it? This one is 4/3 pi. Oops. Okay. Alright, so there's degrees and radians, and you have sine and cosine. I'm sorry, who's positive and who's negative. But now what I want you to do is I want you to fill out only the sine values. What is the sine of 0 degrees? Sine of pi over 6. Sine of pi over 4. Sine of pi over 3, sine of pi over 2. I want you to notice that right? All the sine values in quadrant 1 are positive. Now in quadrant 2, the sine of 2 pi over 3 but since I'm in quadrant 2, the sine values are still positive. Down to pi, sine value is 0. Notice I started at 0, I increased to 1, and then decrease back to 0. Now sine still has the values of 1/2, 1 over root 2, and root 3 over 2, but since I'm in the third quadrant, sine is negative. All the way to when sine at 3 pi over 2, or 270 degrees, is negative 1. When I'm in quadrant 4, I still have root 3 over 2, 1 over root 2, and 1/2, but again, because I'm in the fourth quadrant, all sine values are negative, and when I come back up to 2 pi, the sine of 2 pi is 0. So now I want you to use this, keep this sheet while we recall that the equation of our unit circle, right, x squared plus y squared is equal to 1 squared, which is the same as cosine squared plus sine squared is equal to 1, not a function. I really, really want a function. A lot of math that we know how to do and are going to learn how to do is all predicated on the fact that you've got a function. And this is a circle. A circle is not a function. Fails the vertical line test, right? There's more than one range value for every domain. So if I want a function, well, the first thing I'm going to do is define variables. I define my independent variable to be theta. So how far have I rotated around the circle around the center in degrees, or x around the circumference in radians? And the dependent value I define to be the sine, not the sine and cosine, just the sine of that angle or arc. So we filled in only the sine values, which were the y-coordinates around the circle. Right? That's what we did. Now we're going to take all of those values off the circle. So I want you to fill in these values. Right? We're making a chart. Right? So make yourself a chart in your notes. X is in radians, y is the sine of that arc. So going around the circle at 0 radians, you had 0. At pi over 6, you had a half. And just because I want you to kind of start to get used to or notice some things about these range values, I want you to write approximately, well no, it's actually equal to 0.5. 1 over root 2 is approximately 0.7, and root 3 over 2 is approximately 0.8. Look at the quadrant 1 arcs. The sine of all the arcs in quadrant 1 are increasing from 0 to 0.0 at the boundary, 0.5, 0.7, and 0.8. Y is increasing. Domain, range. Let's go into quadrant 2. Right, pi over 2 is a boundary on the positive y-axis. Then you have 2 pi over 3, 3 pi over 4, and 5 pi over 6. You are at a height of 1 at the top of the circle. Then the sine values are still positive but decrease. 0.8, 0.7, and 0.5. So fill out those values. Notice these y values are positive, but they are decreasing. And decreasing back towards what? The boundary at the negative x-axis. Pi, and the sine of pi is 0. Notice that the quadrant 3 arcs have a sign that is negative, negative 0.5, negative 0.7, negative 0.8, decreasing to what? The boundary on the negative y-axis. And that boundary is at 3 pi over 2, or 270 degrees. The y value, or the sign, is negative 1. The quadrant 4 arcs are all negative because we're dealing with the y-coordinate. So from negative 1, your minimum, you're going to increase negative 0.8, negative 0.7, and negative 0.5. And what are you increasing to? Back to 0. So now turn the page and look at how I've made my axes. Right? Use a straight edge, and I want you to make a boundary mark at 1. No sign value is going to go above 1 or below negative 1, because that's the top of the positive y-axis and the bottom of the negative y-axis. So let's plot these points. At 0 radians, the sign is 0. At pi over 6, the sign of pi over 6 is 0.5. The sign of pi over 4 is approximately 0.7. The sign of pi over 6 is approximately 0.8. Notice the height jump from 0 to a half is much smaller than from going a half to 0.5 to 0.7, and then from 0.7 to 0.8. Then you've reached the maximum of 1 at the boundary. And that's the boundary, that's the positive y-axis. After you're at 1, your next point, you're in the second quadrant, and your sign values are 0.8, 0.7, 0.5. Look at that beautiful symmetry. Why is it a symmetry? Why is there a symmetry? Because you're from a circle, and a circle is beautiful. You finish here from quadrant 1 at the boundary of the negative x-axis. And that value is 0, right? The sign of pi is 0. Now what happens when you go into quadrant 3? What happens to the sign values? Negative 0.5, negative 0.7, negative 0.8. Till you reach the boundary of the negative y-axis. And what is that value down there? What is the sign of 270 or the sign of 3 pi over 2? Negative 1. But after negative 1 you come back into quadrant 4, and what are your sign values? Still negative, but negative 0.8, negative 0.7, negative 0.5, until you all the way back on the positive x-axis. And what is the sign of 2 pi? 0. You've just graphed the sine curve. Since there are an infinite amount of arcs, we can connect these dots. Those are all our specials but in between there are still arcs with sign values. They're just not special values. So connect these dots with a smooth concave up to the maximum. I'm sorry, concave down to the maximum. Concave down through quadrant 2. Hit the x-intercept, which is also poi, because you're going to change to concave up. And you're going to connect these with a smooth concave up graph till you hit the minimum. So you're going to stay concave up, and you're going to hit all your special values. Nice smooth curve until you get back to the beginning. You have just graphed one rotation around the unit circle, which is of course any circle, because any radius can be defined as one unit. One rotation called a cycle. But because there are an infinite amount of coterminal angles, you put arrows on the end of this to say that you can go back and forward, around and around and around this. Y is equal to the sine of any arc. Now don't get this y confused. You really should write the function f of x is equal to the sine, and I am now a function. Of course, you can also write that f of theta is equal to sine theta if you're in degrees. Woohoo! So, let's talk about some characteristics of this graph. Again, I think it's probably less confusing if instead of writing y is equal to sine x, you write this in function notation. F of x is equal to sine x. Oops. So remember, you do really have arrows here to indicate your pattern continues forever and ever. Notice you are smooth and continuous. You never go above 1 or below -1. Sine x is a periodic function. Right? I defined those the first day of this unit. So, what values can you put in for x? Remember, x is an arc. So on this circle, how many arcs are there? Right? Well, there's an infinite amount of them. An infinite amount of positive arcs and an infinite amount of negative arcs, right? So your domain is all real numbers. One rotation or one cycle is completed in a distance of 2 pi, the circumference of your unit circle. What about the range, though? What values do you get out of sine x? Your range y or f of x is between 1 and +1, and they are included, right? Where does sine equal to 0, right? And you only have to give me on one cycle, right? Since this cycle repeats, you only have to give me the 3 x-intercepts. Where does sine equal 0? Well, you think about the y coordinate on the unit circle, right? x-intercepts, I guess I should write this underneath so it doesn't disappear. X-intercepts are at 0 radians, pi radians, and 2 pi radians, right? This point is 0, 0, label that, pi 0, and 2 pi 0, the boundaries. How about a y-intercept? When you plug in 0 for x, what do you get for sine of 0? Sine of 0 is 0. That's already graphed. How about maxes and mins? Look at your range. You have an absolute max of 1 and an absolute min of -1. Right? There are no, I mean, there are also technically locals, but they are absolute max and min. Look at the table that we made. When do sine values increase? In what quadrants? Sine values increase in quadrant 1 and quadrant 4. How about decrease? Sine values decrease in quadrant 2 and quadrant 3. So how are you going to write that? Increase in quadrant 1. You only have to give me over one cycle again. Right? Just give me, even though the domain is negative infinity to infinity, the characteristics you only have to give me over one cycle. So increasing from 0 to the end of the first quadrant, and you can either put an equal sign or not. Label that. Also increasing from the boundary at the positive negative y-axis to the rest of the way around the circle. Decreasing is going to be from the beginning of quadrant 2 to the end right, or the boundary between quadrant 3 and 4. How many points do I have labeled? This is going to become important. On this one cycle of sine, I have 1, 2, 3, 4, 5 points labeled, and I have arrows. Whoops, I don't have arrows on that end, do I? Again, you need to indicate that you have an infinite domain, but you only have to graph and label and give me characteristics over one cycle. How about concave up? Concave up. Nope. Concave up. Yes. Quadrants 3 and 4. concave down in quadrants 1 and 2. So how are you going to write that? Concave up and concave down. Okay. So, oh, I forgot poi. Poi is where you change concavity. Where is poi? Halfway through. Look at the symmetry of this graph. Now, you're not putting this on a characteristic list because I promised you a characteristic list. The only symmetry that you're responsible for on a characteristic list is vertical symmetry, like in our parabola and our absolute value graph. But I do want you to notice that there is a symmetry to this graph. If I were to continue the graph, right, off to one side, can you see how you could spin it around the origin? Right? Spin it around the origin and it would match, right? That's called point symmetry. You're not responsible for that, but it is kind of neat to name that on a characteristic list, but it's kind of neat to look at it. So what is your homework? You have to repeat this entire lesson, which means the chart O values, the graph of one cycle, and the characteristic list, but for cosine. So how do you do that? You go all the way back to the beginning, to the very first handout that you had, the beginning of this packet, and instead of filling in the sine values, you fill in cosine, right? So the cosine of 0 is 1, root 3 over 2, 1 over root 2, 1/2, and 0. Then do the chart, and then do the graph, and then do the characteristic list. Okay? One last thing that I want to make mention of is when you're writing, for instance, the sine of 45 degrees is 1 over root 2. There are some textbooks and some multiple choice answers that don't like to have a radical in a denominator. So you will sometimes see this radical in a denominator gotten rid of. The technique or the name of that is called rationalizing the denominator. Right, and that should make sense to you if you think about the root word here. Look at me getting English into the math classroom. Rational. Right now the square root of 2 is not rational, it's an irrational number. But if I multiply it by 1, which is root 2, a 1 is root 2 over 2, I can say that the sine of 45 degrees is root 2 over 2. That is the same thing, right? That is the same value. Just go to, if you don't believe me, just go to your home screen. Hit 1 divided by root 2, and hit the square root of 2. Divided by 2. They are the same number. I just don't want you to be thrown if you see some people write the sine of 45 degrees as root 2 over 2. You need to understand that that is the same number, right? The sine of 7 pi over 6. I'm sorry. 5 pi over 4 is root 2 over 2. But 5 pi over 4 is in the third quadrant and sine is negative. You can write negative 1 over root 2. You just have to recognize that that's the same value. So think about this. Tangent of pi over 6 is 1 over root 3. Can you rationalize that denominator for me? Multiply times a 1. Tangent of pi over 6 could be written as root 3 over 3. You need to understand that is the same thing as 1 over root 3. Okay? I don't need these fractions rationalized. Sometimes when I'm doing trig expressions, I like rationalized denominators, so I have integers when I have to combine fractions. But other than that, I could not care any less about having radicals in the denominator. But you do need to know that on SATs, AP exams, more than likely on the multiple choice, you will see the rationalized version of unit circle values. Not all the time, but most of the time. Okay, so again, for our speed quizzes, remember speed quizzes are coming. I don't have to have the denominators rationalized. Alright, have a great weekend, and I'll see you on Monday. I will check the homework from both Thursday and Friday. Alright, have a good one. See you later.